Hi, hello everyone. This is Dnyaneshwar Sanap, working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In this video lecture, we will discuss about the new topic that is stereochemistry. Basically, the stereochemistry that deals with the study of three-dimensional arrangement of an atom or the group in the organic molecule. The one question arises in the mind: why we study the three-dimensional arrangement of atom or groups in the organic molecule? To answer the same question, consider the one example. The molecular formula for the example is C2H4Cl Br. Basically, this molecular formula having two different structures. The first structure in which CS3, CH, Cl and Cbr bond. In second structure, CH2, CH2, Cl and Br. These two molecules having same molecular formula but different in the structure. In case of first molecule, this carbon atom is chiral in nature. That means all four groups attached to the carbon is different one. But here both carbon atom is not chiral in nature. Let us consider this example. Basically, for this structure, there is two different molecule is formed in the three dimensional because carbon in sp3 hybridization. This carbon in sp3 hybridization in which these four groups, that is first, second, third and fourth, are arranged in the 360 degree around the carbon atom in the tetrahedral geometry. And when we write the structure of molecule in the three dimensional, we get these two structure. The structure first one is in which CS3 and hydrogen and here carbon atom. One substituent below the plane and one substituent above the plane. Similarly, the structure second in which one substituent below the plane and one substituent above the plane, but the position of substituent is changed with respect to the first one. Here bromine atom and here chlorine atom. When we think about these two structures, that is structure A and structure B, that time we found that the properties like chemical properties as well as physical property for both molecules are different, and that's why we have to study the molecular structure in the three dimension is very important. To understand stereochemistry of an organic molecule, we have to understand some basic concept of an stereochemistry. The first basic concept of an stereochemistry is isomerism. Let us see in detail. Let us see the concept isomerism. Basically, isomerism word is formed by the combination of two words. The first one is iso and second one is merism. Iso means same and merism means part. That means same parts. Basically, isomerism is defined like when organic molecule having same molecular formula but different in their physical and chemical property is known as isomers, and the phenomena is called as isomerism. That means organic molecule having same molecular formula but different in physical and chemical properties. Let us see the example. The molecule CS3, C, H, Cl and here bromine. This molecule having two different structural formulas. The first one in which CS3 hydrogen, bromine and here chlorine, and second one in which here hydrogen, here CS3, at the bottom chlorine and at the above side bromine. In these two cases, that is case A and case B, both compound having same molecular formula, but the physical as well as chemical properties of compound A and compound B, or molecule A and molecule B, are different, and that's why these two are, that is A and B, are isomer. And the phenomena is known as isomerism. The next important point is types of isomers. Basically, there are two types of isomer. First one is structural isomer, and second one is stereoisomers. Let us see one by one. The structural isomer further divide into the 6 types, and this stereoisomer is further divided into the 2 types. Let us see one by one. The first type of structural isomer is chain or nuclear isomerism. Chain or nuclear isomerism. The second type is positional isomerism. The third type is functional group isomerism. Fourth type is Metamerism. The fifth type is Catamarism. And sixth type is ring chain isomerism. The second, stereoisomerism, is further divided into the 2 types. The first one is geometrical isomerism. Second one is optical isomerism. This is all about the classification of isomerism. From this, we get a clear idea about the isomerism. The first one is structural one and second one is stereoisomerism. Out of these 2 isomerism, for structural isomer or structural isomerism, we have to study the representation of structural isomerism. Representation of structural isomerism. And second one is conformational analysis of structural isomerism. For stereoisomer, we have to study nomenclature for geometrical as well as optical isomerism and concept of chirality. Let us start the studying of one by one isomerism. The first one is structural isomerism. Let us see the first one, that is chain or nuclear isomerism. Basically, chain or nuclear isomerism arises due to the difference in the structure of an carbon chain which forms the organic molecule. For example, butane molecule. Basically, butane molecule having different structure. First one is N-butane, that is CH3, CH2, CH2 and CH3. The second structure is 2-methyl-propane, that is CH3, CH, CH3 and here CH3. This both molecule having same molecular formula, that is C4H10, but different in the structure. But the different in the structure is only for the chain of carbon atom. Here, for first case, that is N-butane, the carbon 1, carbon 2, carbon 3 and carbon 4 are attached to each other in the straight line. But in 2-methyl-propane, the carbon is attached in the different fashion, that is carbon 1, 2, 3 and 4th. In 2-methyl-propane, this methyl group is attached to the second carbon atom instead of the third carbon atom. And that's why these two isomers of an C4H10 molecular formula are known as chain or nuclear isomers. The another class of compound also shows the chain or nuclear isomerism. The example for that, molecular formula C4H10O. Basically, this molecular formula shows the two different structures like CH3, CH2, CH2, CH2 and OH. The second structure is like this: CH3, CH, CH2, OH and here CH3. Both this molecule, that is molecule first and molecule second, having same molecular formula but difference in the chain of carbon only, and that's why these two molecules are chain isomers of each others. From these two examples, it must be clear that the molecule of chain isomerism is differ only with respect of the linking of carbon atoms in the alkanes or in the alkali groups present in the compounds. The second type of isomerism is positional isomerism. Let us see positional isomerism. Basically, positional isomerism is formed when the organic compounds having same structural formula but different in position of an substituent or group on the carbon chain is called as positional isomerism, and the phenomena called as positional isomerism. Let us see with example. This is the molecular formula. This molecular formula having two different structure. The first structure is N-propyl alcohol, that is CH3, CH2, CH2, OH, and the second structure is isopropyl alcohol or 2-propyl alcohol. The structure is CH3, CH, OH and here CH3. Here, for case first, the chain of carbon atom is like this, and for second, that is 2-propyl alcohol, the chain of carbon atom is like this. In both cases, the hydroxy group is attached at the different type of carbon atom. For N-propyl alcohol, the hydroxy group is attached to the CH2 group, and in 2-propyl alcohol, the hydroxy group is attached to the CH carbon atom, and that's why these two compounds are known as positional isomers, and the phenomena is called as positional isomerism. Let us take another example. The molecular formula C5H10. The first structure of C5H10 is 1-pentene, and the structure is CH2 double bond CH, CH2, CH2 and last CH3. The second structural formula for the molecular formula C5H10 is 2-pentene. These two structures having same molecular formula but different in the position of a double bond. Here, position of double bond in between the carbon number 1 and 2. And for structure second, that is 2-pentene, the position of carbon-carbon double bond is in between carbon number 2 and 3. And that's why these two compounds are positional isomers of each others. And the phenomena is called as positional isomerism. The third type of example for the positional isomer is in the disubstituted or trisubstituted benzene rings. Basically, in case of disubstituted or trisubstituted benzene ring, different type of isomers is possible. Let us see the example. aminophenol, in which the hydroxy and NH2 group is present at ortho position. When this one of the substituent is at the position of 1,3 with respect to each other, then it is known as meta-aminophenol. And when this substituent position is 1,4 with respect to each other, then it is called as para-aminophenol. And these three, that is first one, second one and third one, are positional isomers of each others. That means positional isomerism is present in open chain compound, unsaturated compounds or in aromatic compounds. The next important structural isomer is functional group isomerism. Let us see functional isomerism. Basically, functional isomerism is formed when organic compound having same molecular formula but possess a different functional group, then it called as functional isomerism. Let us understand with the help of example. Molecular formula C4H10O. Basically, this molecular formula having different structure. The first structure, the 2-ethyl group attached to the oxygen and it is known as diethyl ether. The second structure in which the functional group is an hydroxy. The first molecule, it is an ether and second molecule is an alcohol. This is a neutral type of molecule and this is a neutral type of molecule. Let us take the example of another functional group. Let us take the molecular formula C4H8O. This molecular formula having different structure. The first one is N-butyraldehyde. And the structure is the second structure is methyl ethyl ketone, that is CH3 CO CH2 CH3. Here in these two examples, the structure 1 and structure 2 having different functional group. Here the functional group is aldehyde and here the functional group is ketone. But the molecular formula is same. And that's why these two structures are functional isomers of each other and the phenomena is called as functional isomerism. The next important type of structural isomer is metamerism. Let us see it. Basically, metamerism is an isomer which is formed because of unequal distribution of carbon atoms on the either side of an functional group in the molecule. But the molecule belongs to the same class. That means the type of organic molecule is one and the same, then and then it forms the metamerism. Let us see with the help of example. Diethyl ether and propyl methyl ether. CH3, CH2, O, CH2 and CH3. This is called as diethyl ether. And second example is propyl methyl ether, that is CH2, CH2, oxygen and CH3. That is called as propyl methyl ether. When we come across the two molecules, the functional group for the both molecule is one and the same, that is ether functional group. But the chain of carbon on the either side of oxygen is different one. For first molecule, that is diethyl ether, the one side is ethyl and other side also ethyl. But for second molecule, that is propyl methyl ether, one side is propyl fragment and other side is methyl fragment, and that's why these two molecules are metamerism of each other. Let us see another example. Ethyl acetate and methyl propionate. CS3, CO, O, CH2, CS3. This is called as ethyl acetate. And second one is methyl propionate. CS3, CH2, CO, O, CS3. This is called as methyl propionate. In these two examples, the functional group is an ester and the type of compound is neutral. But the attachment of carbon chain on the either side of oxygen is different. For ethyl acetate, the ethyl substituent is attached to the oxygen, and for methyl propionate, the methyl substituent is attached to the oxygen. Similarly, on the opposite side, at alpha position for the ethyl acetate, CH3 group is present, but for methyl propionate, ethyl group is present at the alpha side chain. That means for metamerism, the required condition is the two different molecular formula having same functional group, but the attachment of carbon chain is different one on the either side of a functional group. The next important structural isomerism or structural isomer is an Catamarism. Let us see in the detail. Basically, Catamarism is a phenomena in which the single compound exists in the two readily interconvertible structure. That is, these two structures are different in the relative position of at least one hydrogen atom. That is, the 1,3 migration of proton is take place in the two different structures and is denoted by the equilibrium. That is known as Catamarism, and these two structures are tautomer of each other's. Let us see with the help of example. Basically, the one required condition for the tautomerism, that is requirement of alpha hydrogen for tautomerism. There are two types of tautomerism. The first type is keto-enol tautomerism, and second type is nitro-acynitro tautomerism. Let us see one by one. First one is keto-enol tautomerism. Basically, when ketone or aldehyde having alpha hydrogen, then this alpha hydrogen get migrate with the 1,3 fashion and formation of equilibrium between the keto form and enol form. Let us see with the help of example. Acetone molecule CH3, CO, CH2H. When this hydrogen from the position number 1 is migrated to the position number 3 by tautomerization or 1,3 shift, and the equilibrium is established between the keto form and its enol form like this. This is an enol form. These two isomers is called as tautomers, and the phenomena is called as tautomerism. The example for nitro-acynitro tautomerism is, that is nitromethane. In this case, basically CH3 is attached to NO2 group. Here minus and here positive. This is called as nitromethane. When this alpha hydrogen with respect to the nitro group is shifting via 1,3 migration, it gives an acynitro, that is CH2 double bond N, that is called as acynitro. These two structures are tautomers of each other's. The sixth structural isomer is ring chain isomerism. basically, the ring chain isomerism or isomers is formed when the compound having the same molecular formula but possessing the cyclic or open chain structure are called as ring chain isomerism, and the phenomena is called as ring chain isomerism. Let us understand with the help of example. Propene molecule and cyclopropane. The molecular formula for the both molecule is C3H6 and the structure for propene CS3CH double bond CH2, and for cyclopropene the structure is here. This molecule is open chain and this molecule is cyclic, but the molecular formula is same, and that's why these two isomers are called as a ring chain isomer. This is a ring compound and this is open chain compound. That's why it is called as a ring chain isomers. The another example is 1-butene, cyclobutane, then methylpropane. These three are the examples of a ring chain isomer. The first example is 1-butene, second one is cyclopropane, and third one is methyl cyclopropane. And that's why these three are ring chain isomers of each others. This is all about the structural isomerism in the detail. Next, we will see the representation of organic molecules in the three-dimensional projection formula one by one. Thank you for watching.